Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to talk about how to calculate the present value of future income. This is the only topic we are going to cover from the chapter in the textbook on the basic tools of finance. The present value is the amount of money today needed to produce a future amount of money given prevailing interest rates. Present value is useful because it gives us a tool to compare amounts of money received at different times. In business, decisions often pay off over a long period of time, and it's important to be able to compare those payoffs. We are going to use the variable r to denote the interest rate. R is given in decimals so that we will express an interest rate of 10%, for example, as 0.1. Let's look at an example to get us started. Suppose we have $100 in an account with an interest rate of 5% per year. So we're going to write r equals 0.05. After 1 year in this account, we are going to have 100 times 1.05, which will be $105. It's going to grow by 5%. After a second year, our starting $100 is going to grow by 5% twice. And so we'll take 100 times 1.05, which is 105, and multiply it by 1.05 again, which is 110.25. We can generalize this to build a formula for the future value of money. Suppose we save an amount x, that's what we call our principal, for t time periods. I'm going to use a capital T to denote the total amount of time that we are going to save the money. The future value of that money is going to be x times 1 plus r, and so in our example that was 1.05, to the t power. Every time period, that interest is going to compound again. Working backwards, we can figure out how to calculate the present value. Instead of getting $100 now and saving it for a few time periods, let's think about what would happen if we were to get the $100 sometime into the future. Suppose we got the $100 1 year from now. Had we received the $100 now, we could have put it into the savings account and generated 5% interest. Since we're getting this $100 in a year, we're losing out on that interest. So to calculate the present value of that $100, we're going to divide it by 1.05, and that's going to give us approximately $95.24. This means that $100 received in a year is equivalent to receiving $95.24 now, because we could put that $95 in the account and generate enough interest to get $100 in the future. Continuing on, if we were to instead receive the $100 2 years from now, we would be losing out on not just 1 year of interest, we would be losing out on 2 years of interest. So we're going to divide by 1.05 twice, and so that's going to give us approximately $90.70. So what we can see here is that the farther into the future we receive the money, the lower the present value is going to be. In this case, had we received $90.70 right now, we could save it for 2 years, and after 2 years, it would grow to $100. Just like the future value, we can generalize this to a formula for calculating the present value. Suppose that we will receive the amount of money x after t periods. The present value is going to be x divided by 1 plus r to the t. The greater the interest rate and the greater the amount of time, the lower the present value, because both of those things mean we are losing out on more interest. The idea that money received in the future is worth less than the same amount of money received now is called discounting. So you might hear present value also referred to as discounted value. We can also use this formula to calculate the present value of an income stream over time. We are going to use lowercase t to represent a generic amount of time into the future. We're going to use x subscript t to denote the income in period t. T equals 1 represents one period into the future. So t equals 0 refers to right now. That means x subscript 0, or sometimes called x naught, is income right now. Suppose we have an income stream that lasts capital T periods. The present value of that income stream will be our income received right now, and we don't have to discount that at all, plus the income we'll receive one period from now. That's going to be discounted once. Then our income 2 periods from now is going to be discounted twice, and so on, all the way out until we get our income in our final period, xt, and that's going to be 1 plus r to the t. We can compress this down a little bit by using summation notation. I'm just going to leave the x naught alone for the moment, but I'm going to combine all of these into a single expression. Summation notation uses this big sigma to represent the sum of everything that's inside of it. This means we are going to add up all of the individual present values from each individual period from t equals 1 all the way up to big T. And so this part that I underlined is just compressed into this one expression that I have here. It's also possible for an income stream to go on forever. That is, it goes to an infinite number of periods instead of having a stopping point at big T. In that case, we can write the present value equals x naught plus all of our same summation notation. But instead of stopping at big T, it just goes to infinity. The last thing I want to do here is investigate a special case where we get the exact same amount of income in every single period in the future. And so I'm going to say xt equals just some fixed value x, so I've dropped the t, meaning that all of these xt's are the same value for all t greater than or equal to 1. I'm still allowing x naught, our income right now, to be different, but all of the future ones are going to be the same. And so this is going to give us present value of x naught plus sum from 1 to infinity of just x over 1 plus r to the t. There is a special formula that we can use to very conveniently calculate the value of this. I'm not going to take the time here to show the calculus proof of this. We'll write the present value equals x naught plus x over r. Remember that we can only do this if the income in each of those future periods is exactly the same, that we've just written as x. Let's look at an example. Suppose we have an asset that pays 0 immediately, but in every future period, we are going to receive $100. We're going to continue on with our interest rate of 5%, or 0.05. To calculate the present value of this income stream, we'll just plug in the numbers. X naught is 0. We'll plug that in. X is $100, and our interest rate is 0.05. Dividing by 0.05 is the same as multiplying by 20, and so that's going to give us a present value of $2,000. Note that this is an infinite income stream, but the present value is not infinite. It's $2,000. Even though we will never stop receiving money, from the perspective of right now, money received 100 years from now is not worth very much. And so we end up with a finite present value. This is where we'll stop for the moment. If you have any questions, feel free to let me know. Thanks for watching.